Hello students, welcome to Educate. In this video, we will discuss about the particle nature of electromagnetic radiation. As you already know that the interference and diffraction, the phenomena of interference and diffraction characterizes the wave characteristic of light or any radiation, and the photoelectric effect, black body radiation, and so on. They explain about, or they are the characteristic of the particle characteristic of the light. That is, interference and diffraction is the characteristic of wave. Interference and diffraction, the phenomena of interference and diffraction characterizes the wave characteristic of light, while the photoelectric effect, black body radiation, and variation of heat capacity of solids as a function of temperature characterizes the particle characteristic of light. So that is here interference and diffraction. Okay, black body radiation and photoelectric effect, as well as variation of heat capacity of solids as a function of temperature. That is the particle characteristic of light. That is, now what is black body radiation? Black body, what is black body? This substance, that is the black body, that is the theoretical object. Actually, in the practice, that don't exist. So black body is the body which absorbs the light, or which absorbs the radiation of all the frequency, as well as it could emit the radiation of all the frequency. That is called black body. Black body is the body which absorbs as well as emit the radiation of all the frequency. That is called black body. Practically does not exist, but the carbon black that have of the black body characteristic in a good extent. Okay, and black body, that is a good physical approximation to black body, is a cavity that is here. There is a cavity, that is a small opening, that is a tiny hole. What happened here? Light entered inside this one, and then after diffraction and like that, whatever be that, there be reflection in that, as for example here, black body. So first of all, let's see what is black body. Black body is the body which emits as well as absorb the radiation of all the frequency. That is called black body. Black body Example is here, example carbon black. Listen here. This is a cavity here. In this cavity, through this hole, the light falls. Then after it reflects back here. Then after come here. After that goes to this direction. Then after this direction, and then after this direction. So from here, the light absorbs that body effectively. That is, no radiation takes place from this body. So this object, that is a cavity having tiny hole, that absorbs all the radiation here, all the frequency here. So this cavity acts as black body. So black body here, this object here, what happened? This through this tiny hole, this light energy enters, and then after that remain only in this object. Its walls reflect the light, and the whole light remain in this object only. So this is the example of a cavity having tiny hole, is an example of black body. Usually what happen? Usually when a light falls on a substance, then that substance absorbs some of the energy. That object absorbs some of the radiant energy, and the remaining amount of energy reflects back. And in case of black body, the whatever with the light falls on that don't reflect. So that body is called black body. Usually in any object, when radiation energy falls, then the some portion of radiant energy get absorbed by that object, and the remaining amount of energy reflects back. But in case of black body, whatever with the radiation fall, that gets absorbed totally. That is called black body. Okay. Now what happened here in this, there is a phenomena here which has been observed, the characteristic of black body here. What is that? The intensity. Intensity means amount of light. That means number of photons per unit area. That is called intensity. Intensity is that, or light and number of radiant energy per unit area. That is called intensity. Okay, so this is here intensity here. Usually what happen on increasing, when the amount of light increases, intensity can be also stated as the amount of light. Intensity, the amount of light or the number of photons per unit area. That is called intensity. So what happen when the wavelength increases? When wavelength increases, then firstly what happen? The intensity increases. When wavelength increases, then intensity increases. That goes to the maximum, and that again starts decreasing. That is here. After that, when the wavelength of the light will increase, then after their intensity, that is the number of photons per unit area, that will decrease. Usually on increasing the wavelength, the intensity increases, intensity of light that increases. But after a certain value, then after on increasing the wavelength, the intensity decreases. When temperature will be greater, then on increasing the wavelength of light, there will be no tremendous increment in the amount of light, and then after that also starts decreasing. That is wavelength. It is the relationship of wavelength and intensity. That is the relationship between wavelength and intensity. That is through a black body radiation. On black body radiation, when wavelength increases, intensity also increases. But after a peak value, then after on increasing the wavelength, the intensity decreases. So this one is here. This phenomena is not explained by wave theory of light. The relationship between intensity and wavelength, this relationship of intensity and the wavelength, that has been not explained by the wave theory of light. It has been explained by Planck's. That is particle characteristic of light. The particle characteristic of light was explained by Planck's or Max Planck. So Max Planck explained about the relationship between intensity and wavelength by the emitted by the black body. Okay, that is here. What is here about the quantum? Max Planck have also given the concept of quantum. Quantum is what? This is quantum. Quantum is the minimum energy emitted by the light in the form of a small packet, and each packet of energy is called quantum. Max Planck have given the concepts of quantum, Max Planck, and he stated that the energy emitted by the light are in the form of a small packet, and each small packet of energy is called quantum. Okay, now here it has been explained about this one, Max Planck, that energy emitted by any photon or light, the energy emitted from a photon, that is here, will be multiple of a certain value. That is here, that may be 0, h nu, 2h nu, 3h nu, and nh nu. That means energy emitted by a photon are not in the form of a continuous manner. The energy emitted from a light are not in a continuous manner. That's in a discrete. That's in a simple multiplication of some values. Like energy emitted by a photon will be maybe 0 here, h nu, 2h nu, 3h nu, and so on, and nh nu, like that. So energy emitted from a quantum or a photon are in discrete manner and not in a continuous manner. Okay, in the same way, here example is given here on a staircase. When you goes on the staircase, then anyone will cover the steps in the form of a multiple of some value and not continuously. So that is here, it is here same energy emitted from a photon are in the multiple of some value and this one and not in continuous manner. So energy of photon, that is equal to h nu. Energy of any photon is h nu. Energy of any photon h nu or hc upon lambda. About that you have already studied. Okay, that was about the quantum. What is quantum? So quantum energy emitted from a photon are in the form of small packets, and each packet of energy is called quantum. So energy emitted from any photon will be in the multiple of some values, and that is h nu. So that means 0, h nu, 2h nu, 3h nu, and so on. That is that after then after is photoelectric effect. About that Max Planck and photoelectric effect. Phenomena of photoelectric effect was explained by Hertz. This one. The phenomena of photoelectric effect was explained by Hertz. What is actually photoelectric effect? As the name indicates, photo and electric. So when a photon strikes to the metal surface and the electron from the metal surface ejects, then that phenomena is called photoelectric effect. As the name indicates, photoelectric. Photo means photon and electric means electricity or electron. So when a photon having energy greater than or equal to some value, some fixed value, when a photon having energy greater than or equal to a fixed amount of energy falls on a metal surface and the electron from the metal surface ejects, then that phenomena is called photoelectric effect. So photoelectric effect is the phenomena of ejection of electron when a photon having sufficient energy falls to a metal surface. And the phenomena of photoelectric effect was explained by Hertz. Now let's see. There is a metal surface. Electron is here. When a photon strikes here, then some amount of energy, then what the photon should have the energy. So this photon should have minimum energy to cause the photoelectric effect. That will be called, this one, that will be called work function. So work function is the minimum amount of energy which the photon must possess to cause the photoelectric effect. So that is, work function is the minimum amount of energy which the photon must possess to cause photoelectric effect. That is called work function. What happened when a photon, here this, the electron is tightly bonded to here. So when a photon strikes on this one, okay, firstly, then after goes on the threshold frequency. Let's see. Firstly, work function. So work function is the minimum amount of energy which the photon must possess to cause the phenomena of photoelectric effect. That is called work function. So suppose a photon is striking to the metal surface and it causes the phenomena of photoelectric effect. So energy of photon is h nu. So and energy of radiation is directly proportional to frequency. Energy of photon is directly proportional to the frequency of photon. So that means here we indicate this one as nu naught. So this one is called threshold frequency. So threshold frequency is the minimum frequency of photon which will cause the photoelectric effect. That will be called threshold frequency. Work function is the minimum amount of energy which the photon must possess to cause the phenomena of photoelectric effect. That is work function. And here, so threshold frequency will be the minimum frequency of photon which will cause the phenomena of photoelectric effect. That will be called threshold frequency. That is called threshold frequency. What function is that? Threshold frequency, the minimum frequency which possessed by the photon to cause the phenomena of photoelectric effect. That is threshold frequency. Let's see about this diagram. About this diagram, let's see. There is a metal surface. There is a metal surface here of light having energy greater than some value. A photon having energy greater than some value that strikes to the metal surface. As a result, from the metal surface, the electron get ejects. Here, this metal is acquiring negative charge. Here is positive charge. So then, after this electron ejects from the metal surface, and this electron get attracted toward this detector, which is positively charged. So electron will flow from this direction. So electron flows in this direction, and as a result, here from the ammeter, what will be the value of current that can be calculated here. Okay, that has been connected to this one. This is a vacuum chamber. Arrangement in this diagram is there is a metal surface in a vacuum chamber. To the metal surface, a photon or light strikes, and that light causes the phenomena of photoelectric effect. So that light causes the ejection of electron from the metal surface. That ejected electron get accelerated towards the detector, and then after it crosses the ammeter and reach to the battery. That is here. So this phenomena is called photoelectric effect here. That is light energy falls on the light having energy greater than some value that falls on a metal surface and causing the ejection of electron. So this is called photoelectric effect. What happens, suppose, let's see a metal surface here. When the light falls on that, energy of this one photon is E, and this electron is here, some amount of energy will require to dissociate this bond between the nucleus and the valence shell. That is, this electron is bonded to the nucleus through some energy. When a photon strikes to this electron, then what happens? Some amount of energy will require to cause the ejection of electron, and that will be called work function. And if E is greater than W naught, that means if the energy of photon falling on the surface of metal will be greater than work function, then this electron rejected, and that will come in a motion. When a photon having energy greater than work function will fall on the metal surface, then the electron from the metal surface will eject out, and that electron will come in the motion. In other words, the remaining amount of energy that will convert into kinetic energy of electron. So that means E minus W, that it will be equal to kinetic energy of electron. Or in other words, energy of photon that will equal to work function plus kinetic energy of electron. When a photon strikes to the metal surface, which is sufficient to cause the photoelectric effect, then some amount of energy will spend to eject the electron, and the remaining amount of energy will convert into the kinetic energy of electron. Okay, in other words, this photon here their light will be called h nu, and this work function will be h nu naught plus kinetic energy of electron. So kinetic energy of electron, that can be also written as, so kinetic energy of electron, that can be also written as h nu minus h nu naught, or that will be equal to h into nu minus nu naught. So kinetic energy of electron, that will be equal to h into nu minus nu naught. Nu means the frequency of photon which is falling on the metal surface, and nu naught is the threshold frequency. So here the nu naught is threshold frequency. So nu is and nu naught is threshold frequency. H is Planck's constant, everyone know. And that equal to 6.6 into 10 minus 34 joule second. That is about the threshold frequency, the work function, and the kinetic energy of electron. This one dual behavior of so let's see here, then after is here. So dual behavior of electromagnetic radiation. Albert Einstein has been given the concepts of photoelectric effect. Hertz, firstly, this one have explained about the photoelectric effect, and the Einstein has given a detailed explanation about the phenomena of photoelectric effect using Planck's quantum theory. So keep in the mind, the phenomena of photoelectric effect was firstly reported by Hertz, and the phenomena of photoelectric effect was explained by taking the concepts of Planck's quantum theory by Albert Einstein. That is here. Now, dual behavior of electromagnetic radiation. As we have discussed here, some of the phenomena of light could not be explained by the particle nature of light, like interference, and the phenomena of interference and diffraction could not be explained by considering the particle characteristic of photon, or the light. In the same way, the phenomena of black body radiation, photoelectric effect, and the variation of thermal capacity with temperature could not be explained by wave characteristic of light or the wave characteristic of photon. So it is well known that the dual behavior of electromagnetic radiation, the light could be considered as a particle characteristic as well as wave characteristic. So nowadays scientists are accepting as light as a particle, as a wave. So scientists nowadays is considering the light as a dual, that is dual behavior, that is light behaves as a wave as well as a particle. So interference and diffraction, that's explained about the wave characteristic of light, while the phenomena of black body radiation, the photoelectric effect, and the variation of thermal capacity with temperature, that is here explain about the particle characteristic of photon, and nowadays the dual behavior of electromagnetic radiation has been accepted. Now let's see this question. Watch out this question. Solution: frequency of the photon is 5 into 10 power 14 hertz, or that is second inverse. Second inverse is also called hertz. So you have to find out the energy of 1 mole photons. So here energy of 1 photon. Energy of 1 photon will be h nu. That means 6.6 into 10 minus 34 joule second. That into 5 into 10 power 14. That is hertz, means second inverse. So second and second inverse will cancel out. So a unit will come in joule. So now here 6 5 is 30, carry 3, 6 5 is 30 and 3, 33. Decimal is after this one. 10 to the power how much? 34 minus 14. That is minus 20. Minus 20. So that will be that much joule. That is the energy of 1 photon. Now you will have to calculate the energy of 1 mole photon. So energy of 1 mole is 6.022 into 10 power 23. So energy of 1 mole photon will be energy of 1 photon into 6.022 into 10 power 23. Now calculate this one. That means 198 kilojoule. So energy of 1 mole photon will be 198 kilojoule. Okay, near about. Okay, here 199.51. Watch out this question carefully. What the question is? Question is the power of that bulb is 100 watt and the wavelength of the light emitted by that bulb is 400 nanometer. You will have to find out, calculate the number of photons emitted per second by the bulb. That means from a bulb whose power is 100 watt, that from that bulb the light emitted is whose wavelength is of 400 nanometer. And question is here that you will have to calculate in 1 second how much photons is emitting. So guys, power of the bulb is 100 watt, means the from that bulb in 1 second 100 joule of energy is emitting. Power of the bulb is 100 watt, means that bulb is emitting the energy equal to 100 joule in 1 second. So in 1 second 100 joule of energy is emitted by that bulb in the form of radiation, and the energy of one photon is 400 nanometer. So if we calculate the energy of one photon and total energy emitted by the photon, that means total, because the bulb is emitting energy in the form of photons only, so total energy emitted is 100 joule. Then in 1 second how much photon is emitting, that is we can calculate. So let's see. Here wavelength of the light has been given, so that's we can write Sc upon lambda. Here it is joules into second, joule into second, it is meter per second. So second cancel out. Here it is meter, so meter cancel out, so that will be in joule. So 6.6 into 3, so that is 6.6 into 3, that upon 400. How much is there? It is 17, so 34 minus 17, so 10 power minus 17, that much joule. That is energy of one photon. So total energy emitted that much. Okay guys, that is here. Now let's see this question. Watch out this question. So let's see this question. This is of the photoelectric effect. That is here, when a photon, when electromagnetic radiation of wavelength is this one falls on the metal surface of sodium. So what will be the energy of that radiation? Energy of that radiation, firstly that you will have to calculate. So energy of that radiation, and when electrons eject from there, then their kinetic energy is that much. So work function that you can calculate, and what's the minimum energy needed to remove this electron from sodium? That is work function or minimum energy needed to remove the electron from sodium, that you could calculate. And then after, what will be their wavelength? So what will be the energy of that photon? That we can find out the wavelength also. Let's see here. So energy of photon will be how much? Energy how this one joule? Meter cancel out, second inverse cancel out, so that will be joule. Yes, this one, energy of one photon is this much joule. Kinetic energy of electron, that is given here, that much joule per mole. So here, energy of photon of 1 mole photon you will have to find out then, because it is the energy, kinetic energy of photon, electron in joule per mole. That is, it is the kinetic energy of 1 mole photon. So energy of it is 1 photon. This one is 1 photon. So now energy of 1 mole photon you have to find out. So this is here energy of 1 mole photon we have calculated, because it is here the energy of 1 mole electron has been provided. So energy of 1 mole photon is calculated. Then after, the energy of, so remaining here energy will be how much? So you already know, equal to h nu plus kinetic energy of h nu naught plus kinetic energy of electron, or E equal to work function W naught plus kinetic energy of electron. So this is here, energy of 1 mole photon is 3.98 3.98. That will equal to work function plus kinetic energy of one photon is 1.68. That you calculate by yourself. Okay, so that will be, and now, oh, 10 power 5 here. Okay, so now from here also 3.98. That is joule per mole. In terms of joule, you can for per atom also you can find out. If you will divide by 6.022 into 10 power 23, then you will find out the work function in per atom. Right now it is per mole, that much is the work function. Per atom will be also you can find out. Then it will be joule per atom. This one. Now wavelength of light you can also find out, this one here. So wavelength of light, this is the energy, that upon C, because you know already E equal to C upon lambda. As E is that much, H you know, C you know, lambda you can find out. Okay. Now this question you solve by yourself. This question you solve by yourself. Okay. About that, if because this question is too much easy, so that question you solve. It's all for this class. Thank you, Team Educate.